Hello everyone and good day. In this video, I'm going to teach you how to build an inverter that converts 6-volt DC voltage to 110-220-volt AC voltage using only one transistor. Please be aware that the inverter we're building in this tutorial has a low wattage and will need to be amplified for use with lights. However, this is a great low-cost starting point for more advanced projects. Now let's build the inverter together and see what devices we can power with it. In this schematic, you can see the complete design of a single transistor inverter. As shown, to build this inverter, we need a 6-volt transformer. You can use a 500 milliamperes or 1A transformer, but I'd recommend using a 2A transformer for better efficiency. The transformer should have an operating voltage of either 110V or 220V AC to 6-volt AC, meaning it converts 110V or 220V to 6 volt. So, our transformer is a step-down transformer. Alright, so how does the circuit work? First, let's explain, and then we'll move on to building and practically testing the circuit. Alright, as you can see, our entire circuit consists of a 6-volt 3-terminal transformer, a 13007 transistor, and a 100-ohm 2-watt resistor. The circuit connections are as shown here, and I'll explain them further in the next steps. We connect the 6-volt DC to the center tap of the transformer, which is usually considered the negative in a standard configuration. However, in this setup, we're using the transformer in reverse. One of the positive leads of the transformer connects to the base of the transistor, with the 100-ohm 2-watt resistor placed in line. This is exactly what you're seeing here. The other positive lead of the transformer connects directly to the collector of the transistor, with no components in between, just a straight connection to the collector. The emitter pin of the transistor connects to the ground of the circuit. And here we have the input for our circuit, where we need to supply 6 volts DC. So, our AC power output is from the other side of the transformer, which has 2 wires. This is where we'll get the required power, now converted into AC voltage. The circuit works by having the transistor quickly oscillate to convert the DC voltage into AC. However, it doesn't increase the voltage level itself, just changes it from DC to AC. Then, since this 6-volt AC is fed into the transformer in reverse, our transformer, which was initially a step-down transformer, now functions as a step-up transformer. As a result, the AC input voltage is amplified, and we get a high AC voltage at the transformer's output. Also, note that the voltage frequency increases. This is because the secondary winding of the transformer has fewer turns than the primary winding. Therefore, for the circuit to work correctly, we need not only to convert the DC voltage to AC, but also to increase its frequency. This frequency boost is also managed by the transistor, as transistors, as you may know, switch at high frequencies. In this circuit, the transistor acts as a high-speed switch that turns on and off rapidly. To determine the operating frequency of the transistor, we will measure it with an oscilloscope after setting up the circuit, allowing us to observe the frequency directly. Correct? We decided that our circuit would run on 6 volt, meaning we'd input 6 volt. However, we started with 3V to first measure the AC output and see what AC voltage it produces. Then, we can increase the input voltage level to 6 volt. Alright, let's go ahead and set up our circuit practically to see which devices we can power with it. As mentioned, we'll also measure parameters like the operating frequency and check out the waveform to see if it's sinusoidal or not. Correct? We decided that our circuit would run on 6 volt. Meaning we'd input 6 volt. However, we started with 3V to first measure the AC output and see what AC voltage it produces. Then, we can increase the input voltage level to 6 volt. As you can see, we're getting about 150 volts AC here, meaning that the 3V DC input is successfully converted to 150 VAC at the output. So, our inverter circuit is working. By observing the initial output voltage, we'll now increase the input voltage to 6 volts. As we increase the input voltage, you'll notice the AC output voltage also rises, reaching over 200 volts after observing 250 volts AC. We'll slightly reduce the DC input voltage to 5 volts to stabilize the output voltage around 220 volts. Then, we'll use a light bulb for the final test of the circuit. We reconnect the input voltage. As you can see, this inverter was able to power a 220V lamp with just 6V input, which shows that our inverter is working perfectly. To prevent the transistor from overheating, be sure to use a heatsink so that the heat generated by the transistor is effectively dissipated. Alright, so our inverter worked perfectly and was able to light up a lamp, all with just 6 volts. Now next up, we want to observe the waveform generated by the inverter. Now I turn on the circuit so that we can see the waveform in the oscilloscope. As you can see, the waveform produced by the circuit is similar to a sawtooth wave. Well, now let's see how much the generated frequency is. Well, as you can see, the generated frequency is about 1 kHz. So we made an inverter that converts 6 volts DC into a sawtooth waveform with a frequency of 1 kHz. This frequency reaches the input of the transformer, and as a result, we have 110 to 220 volts AC at the output of the transformer, with which we can light a lamp. Well, this is a simple inverter that worked well, and of course we will make more professional and powerful circuits in the next sessions. Join us to follow the next sessions and CWS Electronic channel.